video will be about ellipses. So an ellipse is another conic section. And one thing to note about ellipses is that circles are actually special ellipses, similar to the way that square is a special type of rectangle. And I'll demonstrate what that means a little bit later. But for right now, what you see on the screen is an example of an ellipse. And the equation for an ellipse follows the form you see: x squared over a squared plus y squared over b squared equals 1. And right now the ellipse is set so that a equals 5 and b equals 3. And there are two imaginary points that are labeled on the graph of this ellipse. Right now they're currently at 4, 0 and negative 4, 0. Those points represent what are referred to as the foci of the ellipse. Foci, spelled F-O-C-I, is the plural of the word focus. So every ellipse has two foci. And we'll see how we can do the math to figure out where those foci are. One thing you may have noticed about the foci for this particular ellipse is that we have these values for a and b, 5 and 3, and we see the foci are at 4. And those numbers should be pretty familiar at this point because of the idea of we have such thing as a 3, 4, 5 triangle. Now, couple things, a couple properties about ellipses that are pretty cool. So because this is an ellipse, I can pick any point on the ellipse, and I could draw lines connecting that point to one line segment connecting a point on the ellipse to one focus, and another line connecting that point to the other focus. Now, if I add those distances together, I'll get a sum. If I then pick some other point on the ellipse and connect that point to the foci in the same way, and add those distances up, I should get the exact same sum. That is what makes an ellipse an ellipse. It's a set of all points whose sums of the distances to the foci is a constant. Now, what you see right now is A, the number underneath x, is larger than B. And as a result of that, that makes two things true. It means that we have a major axis and a minor axis. The major axis is horizontal in this case, and the minor axis is vertical. If I adjust the values so I make B larger, we now see that the major axis becomes vertical, the minor axis becomes horizontal, and our foci are always going to be on the major axis. So now our foci are on the y-axis here because B, the number underneath y, is larger than A. And as I mentioned at the beginning, a circle is a special type of ellipse. So if I make A and B the same, we see that our foci now are at the origin, at the point 0, 0. And we now just have a circle with radius of 5. So this could be another way that you could write the equation for a circle. Now, the relationship between the foci, those coordinates, and our A and B values is that we can always find the coordinates for the foci if we know what A and B are. So let's go to the iPad and I'll show you how some of that math works. Many textbooks consider the idea that you can have two different forms of an ellipse equation. One is where we have x squared over a squared plus y squared over b squared, and the other is where we have x squared over b squared and y squared over a squared. The idea here is that A is always going to be larger than B. So whichever those values in the denominator is larger, we'll generally consider that to be A. C is the letter we're going to use to represent where the foci are. And to calculate C, you're going to take A squared minus B squared and set that equal to C squared. So you should notice this is very similar to the Pythagorean theorem, except we're subtracting instead of adding. So as I said, we have two types of ellipses. When A is in the denominator underneath x, then we'll have a horizontal major axis. Our vertices will be at positive or negative a comma 0. What are referred to as our co-vertices will be at 0 comma positive or negative b, and our foci will be at positive negative c comma 0. Once again, we get c from the equation c squared equals a squared minus b squared. If the larger value, the a squared, is underneath the y squared, then we will have a vertical major axis. Then we'll have vertices at 0 comma positive or negative a, co-vertices at positive negative b comma 0, and foci at 0 comma positive negative c. And by always considering a to be the larger value, that allows us to think of the equation to find c is always going to be the same. You're always going to take the larger value, a, square it, and subtract the smaller value, b, squared, to find c squared. So that's an introduction to ellipses. The next video will go into how to use some of this math to either sketch a graph of an ellipse from an equation, or how to write the equation of an ellipse given co-vertices, vertices, and or foci.